Hi everyone. My name is DJ. We are going to talk about stress. Definitely, it's a scientific or engineering term for stress. We will talk about the definition first and see some examples. Uh, Many of you guys will be very familiar to the term of distress. Actually, I'm pretty sure it's one of the most fundamental concept of material engineering. Definition of stress is the in magnitude of force on a unit surface, unit area. So firstly, let's assume that there's a bar in the space. When we apply a load, same load in opposite direction, this bar should be extended a little. There will be a certain amount of deformation in this bar. So if you cut through this bar and think about this cross section. If you assume that this axial force is applied act on the surface equally distributed, and if we divide the axial force with unit area and area of this surface, then we call it normal stress, and usually use the Greek character sigma for it. And it can be tensile force and tensile stress, and also compressive, depends on direction of this force. If you good.
Why name as a stress? Why they didn't say force or other terms? Why they say stress?
Yeah, good question. Forces only have the magnitude. I don't mean stress has another direction or another term in it. It is the scalar property, but we have to let's think about this. How do you define the strength of a certain material? And if you have to if you have to calculate the strength of certain material, you should use the term. You shouldn't use the term of force, because we don't know if it has a very small strength. If you think about the very small amount of strength, but you have much of that material, it definitely have a much more strength than a very thin or very small material. So you need to generalize the force term by dividing. In this case, by dividing it as a unit area. Dividing it by area to turn the force term into the unit area term. And also there's another type of stress. We call it shear stress. Let's assume that a plate is fixed by a board. This is board fixing the two elements. Okay.
Are you gonna give the formulas on the exam to us, or do we have to memorize?
Depends. It depends. It surely depends, but I assume that exam is much more complicated than this simple situation, simple example. is very basic concept. Is it should be memorized. This thing. Okay. You realize what this situation? There is a hook-like element here, and there is a plate holding them, and the two elements is fixed with the bolt. This is bolt, and we apply the same load here and here. And in the case, let's focus on this material, this part. There, if we apply a tensile force in this direction, there must be pressure on this part. We focusing on the board part here, and there also be a pressure in this part. We call it bearing pressure on this part and this part. And if we focus on this material, what happens to this part and this part of this particle? Okay. In this case, the normal parts, the applied load is act on the perpendicular normal to the surface. But in this case, the applied load is acting on the cutting surface. So what happens if you push it very hard? The bolt will be sheared. So we call it shear strength in this case. As I told you, I will look up some example for it. Let's think about the hammer. You definitely apply a load in the head of nail. It is push the nail head into ground. Not ground, or wood or certain material, concrete. You hammering it apply the normal stress to the nail, and some of the stress go to exerted in the lower material. And if you use a scissor, okay, it definitely